Now this root locus technique. Now what is the root locus? Oh, see this definition. Root locus actually, the definition actually in this one there are two definitions. In this one there are two definitions. So first definition is actually it is the plot. Actually it is, first let me write the definition. It is the plot of the locus. It is the plot of the locus, or that we can as a path. Okay, so it is a plot of the locus of the closed loopholes of the closed loop holes. This closed loop holes as a function of the open loop gain, as a function of the open loop gain. This open loop gain, that is K. Okay, when K is varied from 0 to infinity. Clear? So let me just again define this word by word. So what is the root locus? Root locus actually it is the locus. Locus means that is a collection of point. That is a collection of point. So if we connect all the point, these point are what? That is the closed loopholes. This is the closed loopholes. This one is the closed loopholes. Correct? It's a path. It's a path of closed loopholes. That it will clear very soon. What are the closed loopholes? Okay. So it is the path actually. It is the path, or it is the collection of all the closed loop poles. This closed loop poles as a function of open loop gain K. This closed loop poles, this is the function of open loop gain K, where K is varied from 0 to infinity. Where K is varied from 0 to infinity. So let me give just an example. This definition is clear. Just for the timing, just you understand. This root locus, it is the plot. It is a plot, or it is the collection of closed loopholes. It is the collection of all closed loopholes. What does it mean? So let's say example. GS. GS is equal to K divided by S. Okay, where the unity feedback is there, HS is equal to 1. Now closed loop poles are that is 1 plus GS HS is equal to 0. That is my closed loop poles. 1 plus GS HS is equal to 0. So if I put GS and HS here, then 1 plus, that is K by S into my 1 is equal to 0, or can I write S plus my K is equal to 0? Clear? So this closed loop poles, this is a closed loop poles. S plus my K, that is equal to 0. That if I put the different value of K, I will get the different closed loop poles. So if I put K is equal to 0, then I will get one pole that is at origin. If I put K is equal to 1, I will get one pole, S is equal to at minus 1, like that. If I put K is equal to 2, I will get another pole, S is equal to minus 2. So this pole 0 map, here this pole 0 map, if I put K is equal to 0, this is K is equal to 0, so one pole is at origin. K is equal to 1, one pole is at minus 1. K is equal to 2, one pole is at minus 2. So the point is the collection of all the closed loop holes. If I plot, or if I connect all the points mean that is a poles, location of poles. If I connect all the closed loop poles, this closed loop poles, definitely is a function of open loop gain k, where k is varied from 0 to infinity. That is the definition. So if I connect all the closed loop poles, that is my root locus. It is very simple. Very simple. So if I put this k is equal to infinity, then s is equal to minus infinity. One pole is at minus infinity. So this is my locus. This is my root locus. Simple, very simple. Can I repeat one more time? Point is, it is the plot of the locus, or it is the collection of all the closed loop poles. It is the collection of all the closed loop poles. This closed loop poles is a function of open loop gain k. How it is function of the open loop gain k? Let's suppose, next example, suppose gs is k divided by s square. hs is equal to 1. Correct? Now again this closed loop poles, who will give me the closed loop poles? 1 plus GSHS is equal to 0. 1 plus GSHS is equal to 0. First let me just clear one thing. The poles always are responsible for the stability. Zeros are not responsible for the stability. That we will just clear this concept whenever this full-fledged subject is will that become. Okay. So now the closed loop poles, who will give me the closed loop poles? 1 plus GSHS is equal to 0. Clear? Wait. Okay. So now 1 plus GSHS is equal to 0. Correct? So this is the closed loop poles. So now closed loop poles, now you put 1 plus k divided by s square into my 1 is equal to 0. Correct? Now s square plus my k, that is equal to 0. So if I put the different value of k, because k here as per my definition, that is k is varied from 0 to infinity. So if I put the different k, I will get the different closed loop poles. So this s is what? This minus plus minus j of root k. Clear? So if I put, suppose k is equal to 0, then simple, that s is equal to 0. If k that is equal to 0, my one pole is at origin. If k is equal to 1, I will get the two pole. Okay, that plus minus with j. Clear? If k is equal to 2, then again the two pole, that is plus minus with j of root 2, like that. So now pole 0 map, this pole 0 map, this is the pole 0 map. So k is equal to 0, so this k is equal to 0, one pole is at origin. Okay, this is k is equal to 0, k is equal to 1, two poles are there at plus j and at minus j. Correct? K, this is at k is equal to 1, k is equal to 2, another j root 2, like this. So another pole is minus में j root 2, another poles are minus में j root 2. So the collection of all this collection of all the point, not on here point meaning is the closed loop poles. So I should say it is the collection of all the closed loop poles. It is the collection of all the closed loop poles. Which is the function of open loop gain k, where k is varied from 0 to infinity. If I vary the open loop gain k, I will get the different closed loop poles, and collection of all the closed loop poles is the root locus. It's very simple. Clear? Actually, this root locus, this term that is root, that is locus. Okay, so that is roots mean that is the closed loop poles. Roots mean that is the closed loop poles. Is a dictionary meaning, kind of. That this one is the closed loop poles. What is the meaning of this roots? That is the closed loop poles. What is the meaning of this locus? What is the meaning of this locus? Locus, that this word that is comes from that Latin, that is meaning is, that is path. Okay, that is, this one is, that is meaning is path. So that is the point. So this is the definition kind of. So this definition that comes from this word itself. It is the path. It is the path of the closed loop poles. And this closed loop poles is a function of open loop gain k, where k is varied from 0 to infinity. Correct? Okay. Now, what is the problem in this definition? What is the problem? What is the problem in this definition? Can you please tell me? What is the problem in this definition? Yes. Can you please tell me what is the problem in this definition? This definition is very clear, as this name suggests, that is the root locus. What is the point? What is the problem in this definition? Can we just calculate all the closed loop poles? So the point is, as the Samir said, it is very difficult to obtain the closed loop poles for all the system. The point is, as order increases, let me write, as order increase, finding the roots of characteristic equation. What is the characteristic equation? 1 plus GSHS is equal to 0. That is the characteristic equation. Okay. So finding the roots of the characteristic equation is very difficult. So hence we cannot draw the root locus by using the characteristic equation. Let me write here. Hence we cannot draw the root locus. Hence we cannot draw the root locus by using characteristic equation. Clear? Let me just take one more example, just to understand this point. This example is, suppose this GS is k divided by s cube, HS is equal to 1. Now S is, that is minus में k to the power 1 by 3. Again, if I take one more example, suppose GS is, that is k divided by s to the power 8, HS is 1. Okay, then again this is very tough to calculate the all 8, because s to the power 3 is there, so there are 3 poles, correct, with different value of k. So s to the power 8, again there is, it's very difficult to calculate all the 8 poles. So point is, as the order increases, it is very tough to calculate the closed loop poles. It is very tough to calculate the closed loop poles, because this closed loop poles, this is the function of the open loop gain k, where k is varied from 0 to infinity. So now what we will do, now we have the second definition. Second definition is, means there is nothing wrong in the first definition, there is nothing wrong, but the point is, it's very difficult to go with the characteristic equation. So we have another alternative. Okay, so now another definition of root locus is, that is root locus, because open loop system that we have given already in the question itself. So root locus starts from the open loop pole, poles. Root locus starts from the open loop poles at k is equal to 0 and terminate terminate means what? Root locus. Means root locus terminate at open loop zeros at k is equal to infinity. This is the second definition. Let me just clarify this word by word. What is the meaning of this? What is the meaning of this first statement? Root locus starts from the open loop poles and terminate at open loop zeros. That is, start at k is equal to 0 and terminate at k is equal to infinity. What does it mean? Okay, so just we have the relation between the purpose of giving the second definition that will be clear very soon. Don't worry. Okay. So now we have the relation between this open loop poles and zeros with closed loop poles. Now we have the relation. Now I am going to find the relation between what? This open loop poles and zeros with closed loop poles. Correct? Clear? Because already I told you, closed loop poles are always responsible for the stability. A system is stable or unstable, marginally stable, that all depends upon the closed loop poles. Zeros are not responsible. I am just talking about the closed loop. Zeros are not responsible. Poles are always responsible. Clear? So now the relation between let me complete this relation of this one. After that you will just understand that definitely this second definition, this root locus definition, starts from the open loop poles at k is equal to 0 and terminate at open loop zeros at k is equal to infinity. Okay, so what is the relation? Now consider this closed loop transfer function. Okay, so just open loop is what? That is GSHS. Okay, GSHS is what? That is K of N of S divided by D of S. What is the K? That is the gain. K is what? That is the gain of OLTF, open loop transfer function. And NS is what? That is the numerator polynomial. Okay. Generally, in general, just I denote this N and D, this numerator and denominator. Okay. In place of S plus by 1, S plus by 2, something. Just in place of this, just I denote this NS and DS. NS is the numerator polynomial. NS is what? That is the numerator polynomial. And ds is what? That is a denominator polynomial of open loop transfer function. This is the denominator. This one is the denominator polynomial of open loop transfer function. Correct? Clear? So now this GS, HS, that is the open loop one. Okay. So here this is open loop. So GSHS is equal to K NS divided by DS, where K is the gain, NS is the numerator, DS is the denominator. It's very simple. Now, first point is this case number 1. What are my open loop transfer function zeros? Clear? So, again, I am rewriting this G of GSHS is equal to what? That is K NS divided by DS. So far, any doubt is there? Hello?
No doubt, sir.
Correct. Clear. Correct. So now GSHS is equal to K NS divided by DS. This is the open loop. This one is the open loop. That is given. Clear? So now, what are my open loop transfer function zeros? open loop transfer function zeros, that gives me k ns is equal to 0. Means numerator that gives me the zeros, denominator gives me the poles. Very simple. If I put numerator is equal to 0, suppose let me just take an example just to understand how this open loop transfer function zeros are equal to k and s is equal to 0. Suppose an example, s plus में 2, suppose 2 into s plus में 2 divided by s into s plus में 4. What are my open loop zeros? So simply I put, because this k is k that is not equal to 0, that is k that is a some finite value. So that is ns is equal to 0, that gives me the open loop zeros. So if I put s plus में 2 is equal to 0, so one zeros is at minus में 2. Poles, that is this one I should put equal to 0. So s is equal to 0 and s is equal to minus 4. These are my poles. That is very simple. If I put numerator is equal to 0, that will give me the zeros. If denominator if I put equal to 0, that gives me the poles. Clear? So ns is equal to 0. What should I write? Open loop transfer function zeros are given by ns is equal to 0. Just you keep in mind this, ns is equal to 0. It's very important. Okay, so open loop transfer function zeros are given by ns is equal to 0. Correct? Now case 2. Open loop transfer function poles. Who will give the open loop transfer function pole? I am rewrite just GSHS is equal to KNS divided by DS. Okay. So who will give me open loop transfer function poles? Definitely, if I put this GSHS is equal to infinity, or can I write like this GSHS, that if I put equal to infinity, or this KNS divided by DS, that if I put equal to infinity, that is DS is equal to 0. So the open loop, I should write this open loop transfer function poles are given by ds is equal to 0. This you keep in mind. Okay, this ds is equal to 0. So now in previous slide, the open loop transfer function zeros, who will give the open loop transfer function zeros? Ns is equal to 0. Open loop transfer function poles, that is ds is equal to 0. Clear? Now the third case is, it is very important, this closed loop transfer function poles. So first one is open loop transfer function zeros, second is open loop transfer function poles, and third one is closed loop transfer function poles. So closed loop transfer function poles, they are given by 1 plus में GSHS is equal to 0. That is my closed loop transfer function poles. Is it clear? 1 plus में GSHS is equal to 0. That will give my the closed loop transfer function poles. Let me just take an example. Very simple. Here 2 into same s plus में 2 divided by s into s plus में 4. Correct? If suppose this is GSHS. Now 1 plus में GSHS. So 1 plus में GSHS is equal to 0. That gives me the closed loop poles. So that 1 plus में GSHS is what? That is s into s plus 4 plus में 2 into s plus 2. That is equal to 0. That is my closed loop poles. So if I open this bracket, so s square plus 4 plus 2s plus 4, that is equal to 0. So s square plus 2s plus 8 is equal to 0. So this quadratic equation gives me the closed loop poles. So initially who will give me the closed loop poles? 1 plus my GSHS is equal to 0. Clear? So if I put this 1 plus my GSHS, that is GSHS in general, so 1 plus K into my NS divided by DS is equal to 0. Can I write like this? Correct? So now this one ds plus, if I set this equation k ds plus my k ns is equal to 0. Okay, this suppose this equation number 1. So this equation number 1, this indicate the closed loop transfer function pole. This indicate this one, this is the closed loop transfer function, this poles. This closed loop transfer function pole, this is the function of this is the function of gain k, this is the function of ds, this is the function of ns. Correct? So if ns and ds are maintained constant and k alone is changed, closed loop transfer function pole will also change. This plot is nothing but the root locus. Clear? So if suppose if k is equal to 0, so now if k is varied, my closed loop poles are also varying. Okay. So now point is a part, that is if suppose k is equal to 0. So if I put here k is equal to 0, then can I write this ds is equal to 0 from this equation number 1? Correct? If I put k is equal to 0, because my closed loop, because my root locus starts from the open loop poles at k is equal to 0. That already I written in this second definition, that k is equal to 0. So if I put the very first value of k, if I put very first value of k, that is k is equal to 0, what I will get, this ds is equal to 0. So ds is equal to 0, this ds is equal to 0, which is open loop transfer function poles, which is OLTF poles, which is open loop transfer function poles. You can just cross check from here. This one is the open loop transfer function poles. Clear? So now this open loop transfer function, this ds is equal to 0. What is ds is equal to 0? That is open loop transfer function pole. So can I give one statement here? This closed loop transfer function poles are same as the open loop transfer function poles for k is equal to 0. For k is equal to 0. So thus my root locus starts from the open loop transfer function poles. Thus my root locus starts from the open loop poles. Clear? So now I am going to write this statement here. So the closed loop transfer function poles are same as open loop transfer function poles for k is equal to 0. Thus root locus starts from open loop transfer function poles. Clear? Thus root locus starts from the open loop poles. Now here I put k is equal to 0. Now I am going to put the last value of k, that is k is equal to infinity, the last value, the final value. So as k here, I am rewriting again this equation number 1, or let me, okay, just in the next slide, ds plus k ns is equal to 0. This is equation number 1. I am rewriting again this. Okay, so this b, the case b, that is the final value of k. If I put this k is equal to infinity here in this equation, what I will get if I put this k is equal to infinity. If I put this k is equal to infinity, then as k is equal to infinity in this equation number 1, that is ns is equal to what? This ns is equal to 0. This ns is equal to 0. Clear? Srishti, can you tell me please how this ns is equal to 0 is going to come after putting this k is equal to infinity?
That is because k is n of s by d of s is equal to infinity.
Yes, it means that is if I put here k that is infinity, so that is ds plus that is infinity into my ns that is equal to 0. So this term is dominating as compared to this term. So that is I should ignore this ds. So infinity into my ns is equal to 0. So how it is going to be equal to 0? I should put this ns is equal to 0. So infinity multiplied by 0, that is equal to 0. That is the point. This ns is equal to 0. Correct? Very good. Correct. So now this ns is equal to 0. Now what is the ns is equal to 0? Which is open loop transfer function zeros. Which is open loop transfer function zeros. Which is open loop transfer function zeros. So now can I give one more statement? The closed loop transfer function poles are same as the open loop transfer function zeros at k is equal to infinity. Can I give this statement? Statement is, so the closed loop transfer function poles, because this one case third. This closed loop transfer, this one is closed loop transfer function poles. So closed loop transfer function poles are the same as the open loop transfer function zeros for k is equal to infinity. Okay, so thus, because this is the final point, so thus the root locus ends on open loop transfer function zeros. Point is, thus root locus ends on open loop transfer function zeros. Clear? So when the important point is, when k is equal to 0, the roots of the system are its pole. The roots of the system are its pole. Correct? Another important point is, when k is equal to infinity, the roots of the system are its zeros. It means that the root locus starts at the pole and terminate at zeros as k varies from 0 to infinity. Okay. Now this is the second definition. That is the point. This is the second definition. So where is the definition? This one. Root locus, because closed loop poles, that is the problem in the closed loop poles is what? As the order increases, it is very tough to calculate all the poles of closed loop. Okay, because this closed loop pole, that is a function of open loop gain k. So another alternative is there, that is root locus. That's because this closed loop pole, there is a relation that we derive already, that this one. So now closed loop poles, that is the same as the open loop poles. This one and this one, that is the same at k is equal to 0. And this open loop zeros and closed loop poles, that are also same at k is equal to infinity. And root locus that start at k is equal to 0 and terminate at k is equal to infinity. So that is the another definition, that is root locus that starts from the open loop poles and terminate at open loop zeros. And open loop poles and open loop zeros, that is given in the question itself. No need to calculate the closed loop poles. And one important point is also there, this root locus gives the stability of closed loop system. Let me write here, this root locus gives us the stability of closed loop system. Stability of closed loop system, not open loop system. Closed loop system. Okay. So root locus gives us the stability of closed loop system, not open loop system. The open loop system that we have given. But the root locus starts from the open loop poles and terminates on open loop zeros. It doesn't mean that it gives the stability of open loop system. Clear? Now let me just give an example.